Hello CE284 students. So now I'm trying to record this video to tell you how to use or how to solve the homework 2 questions. I know that you all have done this, so I'm just trying to make some points, just point out what's important. Those questions that are less important or we have already covered in class, I'm not going to cover today. You have the solution already on the blackboard, so that should take care of things. Now let's go over question 1. Question 1: calculate inner and outer products of the following two matrices. Let me open up MATLAB very quickly and let me open a new script. So what you've probably seen already in the classroom, we have seen this to be part of MATLAB. You've seen it within the command window. So basically this is right here. If the editor is docked, it's right here, and then you can click right here and undock the editor. And so this is now the script is the same, so it doesn't really matter if you have it docked or undocked. But these are, that depends on your preferences. I prefer it to be outside, separate actually. So I'm just gonna copy and paste this first line. We'll do the first one, and then the rest it's just easy. You can simply look at them yourself. Let me just copy and paste the first line here. Alright, let me get rid of this. So I have two vectors. A is linear space of 0 to 2, and B is log space of 1 to 7, comma 100. Basically, having this comma 100 or not doesn't really matter, because linear space already has 100 elements. This is this is a vector of 1 by 100. Both A and B are vectors of 1 by 100. Now if you want to do inner product, that would be inner product. If you remember, that's a horizontal vector times a vertical vector, and that should give you a scalar. So A times B prime. So A is horizontal, B is horizontal. B, well, for the inner product we have to have a vertical, so B should be B prime. So this is the inner product. If I now evaluate this, first of all, let me save this week 2 video. Let me actually do CLC and clear first, just to make sure I get rid of everything from the blackboard. So CLC and clear. A is a linear, well, it's a vector, it's a horizontal vector. B is a horizontal vector. In order to have an inner product, we're gonna have to have a horizontal times a vertical, so that's A times B prime. If I evaluate this, I select all this, right click on it and evaluate selection. If I go to MATLAB, you'll see that I have a horizontal vector for A, horizontal vector for B. Both of them are 100 elements, and the inner product is 1.4 times 10 to the power of 8. What you can see here, for to have inner and outer product, the sizes should really match. So it's like the matrix operation, right? So it's multiplying matrices. So the sizes of the two matrices that are multiplied into one another should match. By match, I mean that the inner dimensions should match. So if you have a 1 by 100 matrix, then you can multiply that by 100 by 1. Otherwise it wouldn't be possible. We have covered this in class, so hopefully you remember this. So this is inner product. Outer product is similar in a sense. We are going to use A and B, but in this case it's going to be A prime times B. Why? Because A prime, so outer product should be a vertical vector times a horizontal. If you remember, we should get a matrix out of the outer product. So if I evaluate this, you'll see that we get a lot of elements. If I look at my answer, you'll see that this is 100 by 100 matrix. My answer is 100 by 100 matrix, which is basically what we did. We multiplied 100 by 1 matrix by a 1 by 100 matrix. So what we'll have is basically 100 by 100 matrix. So remember this from the class. That should be easy. Let me move to question 2. Find row-wise and column-wise minimum, maximum, average of the following matrices. This is again very easy, but just for the sake of completeness, I'm gonna cover this. So I'm just gonna copy and paste the first one. Again, I do clear first because I want to get rid of. So I had an A before. I don't want to. I don't. You know, it will replace it in the first place. So I don't really have to do clear. But you know, to be more clean, I'll use a clear anyway. In order to have a row wise or in order to have a column wise minimum, just use minimum of A. But in order to have a row wise minimum, I'm gonna need to use the empty brackets, comma 2. That 2 is the second dimension, which is row wise. For average, we use mean, and again this is mean of the columns, mean of each column, and then mean of each row would be this, and then we have the maximum similar to the minimum. So I'm not gonna do the maximum at all. If I evaluate all this, you'll see that. Alright, it's not working. Why are you using sum? Where am I using sum in my code then? I'm not using sum at all. Oh, okay, so the issue is mean of A. No. Alright, let me go line by line and then we'll figure out what the issue is. So I'll do, let me put this on this side and then this on that side in order to have a better view. Okay, this is better now. So I'll take the minimum. That will give me minimum of each row, minimum of each column. That's perfect. Minimum of each row. That's also perfect. Mean, this will give me mean of each row. And then this is the issue. This is the crux now. Average is not going to work if I'm using empty brackets. How about if I remove that? Well, now it's working. So let me look at let me look at A very quickly. Average of 1, 2, 3, and 4. So mean of 1 through 4 is 2.5. So that's basically, it's doing the right thing. So it's, if I take the average of this one, it's 2.5, and that's what I'm getting. So that's a good thing. So if you remember from the class, we discussed that if you put a comma 2, it will compare each element in A with 2 rather than going row wise. But with average, we don't have that problem, so that empty brackets is not needed. But for maximum, it's again needed. So if I want to do maximum, I just copy and paste the minimum and change minimum to maximum, and that will take care of things. So that's how you do row wise and column wise. And that, you know, you got a sense of how we debug our code. So if you have an error, you know, you can go back and find out why the error is happening and what's going on with this. Perfect. Now let's go to the next question. Viscosity of water could be approximated through this equation. Mu0 is this value, T0 is this value, A is this, B is this, and C. So we have a couple of elements that are given, A, B, T0, etc. For different values of T, temperature, between 273.15 and 373.15, plot water viscosity mu and visually find at what temperature water viscosity is about 0.0006. Add X label, Y label, and title to your plot. Perfect. The only issue is, as you can see, we have a natural logarithm of mu over mu 0, whereas we just need mu, right? So mu 0 is a given value. So if we take the exponential from both sides of this equation, then that's gonna take care of natural logarithm, but we still have mu over mu 0. So what happens is that if we take the exponential first, and if we multiply both sides by mu 0, we will have mu on one side, left side, and we'll have mu 0 times exponential of a plus b times t0 over t plus c times t0 over t to the power of 2 on the right hand side. Now let me write that equation. Again, clear, get rid of everything. Let me write the equation first. So, well, I don't have to do that. Mu, let me call mu m. And then if you remember, we had mu 0 times exponential of a plus b times t0 divided by t. This is not going to work. I'm going to come back to this, but for now, just to write the equation, let me write it here. C times t0 divided by t, and then we have to the power of 2, so we have to have parentheses around this, t0 divided by t to the power of 2, and then we need another parenthesis for exponential. Perfect. Now the issue is, first of all, this equation needs m0, a, b, t0, t, c, t0, t, which we don't have any of them. So let's start defining them. And then we have to define them before the equation. So m0 is equal to 0.001792. T0 is 273.15. A is negative 1.94. And B is negative 4.8. C is 6.74. These are all given. So we've got the given points, but we still don't have t. But as it's given in the question, t should range between 273.15 and 373.15. Well, in this case, always when we want to have a lot of points between two ends of a range, we are going to use linspace. So linspace 273.15 and 373.15. Perfect. 100 elements is good, so I'm not going to define how many elements I need. If I wanted to, I could do 200, 200, or 100, 150. It doesn't really matter. As long as you have enough points, your curve is smooth, you're good. So now let's get to this equation. Now let me run it first and see if it's going to work or not. Remember, I told you it's not. Let's see if it is or not. So, well, clear is not there. So, capital C is lowercase c. Be careful about this. I'm gonna run this, and then I'm gonna get an error. C, m0 times exponential of a was a scalar, perfect. B was a scalar, perfect. T0 was a scalar, divided by t. T is a matrix, or a vector. So t0 divided by t is not gonna work. We want to go element by element on this, because for each element of t, we want to know what is going to be mu. So for each temperature, we want to know the viscosity. So we want to go element by element. We need a dot here. So t0 is a scalar, dot divided by t. So this t0 is divided by each element in t. Similarly, we need a dot here. So t0 dot divided by t. So this is now a vector. Now a vector to the power of 2, we need a dot. So that's perfect. So A is a scalar, B times a vector, scalar times a vector, perfect, no worries. Scalar times a vector to the power of 2, which has a dot, perfect. Exponential can work on a vector, perfect. So now I should have everything. I put a semicolon at the end just to make sure that I don't have I don't want to write everything to the screen. So let me put a semicolon at the end. Let me add CLC to this as well. I don't want to see the previous calculations. So if I do this now, I'm gonna have everything. I'm gonna have my M viscosity, a vector of 100 values corresponding to the 100 values of temperature. The question is asking to plot T versus M. Add legend or X label and Y label. X label is basically temperature values. Y label is viscosity. Perfect. So that's all for now. Title. Title, you can put it anything for now. It doesn't really matter. Viscosity versus temperature. And done. Let me plot this very quickly. So here's my plot. The question is asking what is the temperature for which water viscosity is around 0.006. So we don't really have a 0.006 here, but if you look at the Y range, you'll see that it has a times 10 to the power of -3 here. So that basically this 0.6 is 0.6 times to the power of 10 to the power of -3, which is basically this 0.0006 here. So this 0.6 is what we want. If I just come here, let's see around temperature of 320, that's when we get the viscosity of 0.6 times to the 10 to the power of -3. You would say, this is messy, I can't really follow a straight line. You can do a bunch of different things to help you with visualizing this. You can come here, insert, and then you can put okay, I don't see the grids. Let's go to tools. Okay, I don't see grids here either. Window, maybe this one, no. View, no. Edit. Well, one way to put grids here, if you just put grid on, it will put grids on the figure, and then you can go from 0.6 here, and then you'll see that the temperature is a little less than 320. We'll see this again. Later on when we do root finding. But for now, let's do the visual comparison. In order to, so again, you can put a command grid on, and then it will put the grids on there for you and help you visualize things. The other way you can do is, let me just quickly Google for it. Grid in a MATLAB figure. So grid on, that's how you get grids. But let's see, add grids. Okay, let's see here. Double click on the axis. So let me go back, and instead of grid on, I do grid off for now. So grids are gone. Let's see if I can find axis. Okay, right here. Oh well, okay, no, I don't want to do that. Control Z, it will take me back. Yeah, I don't exactly remember how we did grids. Align, distribute, link brush. Yeah, unfortunately I don't know how to put grids through here. But for now, you can just use grid on and grid off. The other way you can do is to put text box. You care about 0.6, and then use a 0.6, and then bring your text box all the way to here. So your text box now gives you, you know, if you went from 0.6 to this, and then you came back here, and then you can also zoom in here. If you're looking for an exact point, that's about 3.319 or so. Anyway, so that's this one. But the other one, question number 4. Question number 4 now is asking a 3D plotting. Let me quickly download a document that I printed for you. Alright, let me read the question first. In this example, we'll try to plot a dome similar to the US Capitol dome. If we assume x, y values range between -10 and 10, from the corner of the dome and radius is 7 meters, we can use this formula. We'll need to reformat this equation to return z as a function of x and y. So if we keep z here, remove x squared and y squared from this side and add them to this side, what we'll have is r squared minus x squared minus y squared. Perfect. Now the issue that we might have here is this z squared might be negative, because this is 7 squared, and then if you have 10 squared and 10 squared, this is going to go negative, right? So this is not doable. But we can remove all the negative elements and set them as 0. So z2 of z2 less than 0 is equal to 0. What it does is z2 less than 0, it will find all the elements in z2 that are less than 0, and then it will set those elements to 0. We'll talk about this in just a second. Now use the function surf xy comma square root of z squared, because this is z squared, right? So we use square root to plot the dome, and then x label, y label, etc. We'll get to them. But before that, 3D plotting is a little different than 2D plotting. So for a 2D plotting, let's say we have x being 1, 2, and 3, and then y being 1, 2, and 3. So x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. We have 3 points. We can just connect these points together, and we can just plot the line. That's a 2D plotting. That's easy. For the 3D plotting, however, we have some x values here, we have some y values here, and for each pair of x and y value, we have a z value, right? So we have x values, and then for this x, let's say x is 1, we have x1, y1, x1, y2, x1, y3. And then for x2, we have x2 x equal to 2, y is equal to 1, x2, y2, x2, y3, and then x3, y1, x3, y2, x3, y3. So for each of these points, we will have one z value. So like for this one, we come up, we find the z value. For this one, we come up, we find the z value. For this one, we come up, we find the z value. The z values are basically coming. The z values are basically coming from this equation. But before getting there, we need to have, instead of having x equal to 1, 2, 3, we should have x equal to 1, 1, 1, right? So because x is 1 here. On this line, x is everywhere 1. X is equal to 2, 2, 2. And x is equal to 3, 3, 3. And then for this one, y would be 1, 1, 1. Y would be 2, 2, 2, 2. Y would be 3, 3, 3. And now when we have those matrices, because this was 1 for x, right? And then this was 1 for y. So that's what we need, right? We need an x of 1, y of 1. We need an x of 1, y of 2. Mesh grid is going to create this mesh for us. So, all right, let me quickly run this and you'll see what I mean. We want them to be between -10 and 10. But before going into that, let's quickly run a few examples on mesh grid, just so you'll see. Like x was what? 1, 2, and 3. Y was 1, 2, and 3. And then when we do mesh grid is going to create those, instead of having a vector of x values, we'll have a matrix of x values. Let's use mesh grid quickly. Mesh grid of x comma y. See what happens. X was, remember, it was 1, 1, 1, 2, 2, 2, 3, 3, 3, right here, right? So x was 1, 1, 1, 2, 2, 2, 3, 3, 3. That's what we have here. 1, 1, 1, 2, 2, 2, 3, 3, 3. And then similarly, y was the other way, right? So y was 1, 1, 1, 2, 2, 2, 3, 3, 3. And this is what we have. Y was 1, 1, 1, 2, 2, 2, 3, 3, 3. So mesh grid basically created this mesh for us. Now if you want to evaluate our z, that would be like here. Z2 is equal to 7 squared. Again, this is just an example, just to get you give you some information on this. It's not really what we want to do in that in that question, but we'll get to it. Now we'll have xx dot squared, right? So you need that dot because each element should be raised to the power of 2. And then we'll have yy dot to the power of 2. Now we will have a z2, which is also another matrix. That's our matrix. It's, all of them are more than 0, so we don't really have to remove the 0 values or negative values in here. And then if I use surf, you'd see that surf x comma y comma sqrt of z2 will give us a surface. This is a surface. I can't just I can move things around and spin this for you to see the surface a little better. Now let's get back to the question and let's solve the question itself. Clear and CLC, get rid of everything. X was linspace between -10 and 10. 100 values is fine, you don't have to change them. Y could be just similar to x because they're both between -10 and 10. So let's keep them as they are. And then z squared was r squared minus x squared minus y squared. So, well, before doing that, we need to create that mesh grid, right? X comma y, it will create 100 by 100 matrix of xx, 100 by 100 matrix of yy, and then z squared is equal to r squared. R was 7, 7 squared is 7 squared minus x to the power of 2 minus y to the power of 2. So that's my z2. But now if I evaluate this, you would see that some of the values of z2 are negative. See, these are negative. They cannot be, because if you want to take the square root, they cannot be. If I do z squared, z2 less than 0, it will give me all the elements. Let me put them in, I don't know. A is z squared less than 0. A will give me a bunch of values of zeros and ones. So all those z2 values that are less than 0, I'm gonna get a 1. This is uh, relational operation that we just talked about, right? So is this less than 0? Yes, that's a 1. If there are values that are not less than 0, they're gonna get zeros. So because this relational analysis is false, right? So you're not gonna get that any other. And then if we set z squared of z squared less than 0 equal to 0, what it means that find all those elements that are less than 0. So find all those elements, set all those elements in z2 equal to 0. So if I hit enter now, what you'll see, if I go back to z2, you'll see that all those negative values are now zeros, and then all the positive values, they have a value. So that's how we get rid of all those negative values. z2 of z2 less than 0 is equal to 0. So that gives me all the positive value. And then next, to plot this, we use the function serf. Serf of x comma y comma sqrt of z2, that will give me the surface or the dome that I'm looking for. And then it asks for x label and y label. Just call them whatever it's in the question. I'm gonna get to it in just a second. I'm just gonna go there and copy and paste here. So X label was Independence Avenue Southeast, Y label was 3rd Avenue, 3rd Street Southwest. So quickly go back here, this is copy and paste, 3rd Street Southwest, done. And it doesn't really ask for anything else, I guess, so that's done. If I now run this, it will give me the dome that I'm looking for. This is the beautiful dome that I was looking for. See, this is the dome. See, these are all those values that were negative and we set them equal to 0. X is changing between -10 and 10, Y is changing between -10 and 10, and this is our Z value over here. So I hope this makes sense to you guys. And by guys, this is gender neutral, right? So every one of you, I mean. Question 5 now. Download boisetemp.mat. Load it into MATLAB. The file holds minimum and maximum temperature data for year 2013 to 2016 for Boise area. Use 4 subplots, plot minimum and maximum temperature data with blue and red lines. So minimum with blue, maximum with red for each year. X-axis should be between 1 and 365. Y-axis should be between 50 and 50. Add legend with the year. So perfect. So the first things first, I need to have this boisetemp.mat in my current folder. If you don't have it here, you gotta open this, browse for folder, go to the folder that has your boisetemp.mat. For example, if it is in your downloads, you can just click on downloads and then select folder. But this is not in my downloads, so I'm gonna go back to the folder that I have this. So this is the folder that I have this, perfect. I'm gonna load it into MATLAB. So again, I'm gonna use CLC and clear, and then I'm gonna load boisetemp.mat. Just be careful, make sure that your your name, the name that you put here matches the name that's in here, right? So make sure that this is fixed already. And then the next thing that I asked for was subplot. So let me quickly run this. As you can see, there are minimum and maximum temperature for each year. Tmax of Boise 2013, Tmax 2014, Tmax 15, 16, and Tmean same thing. subplot 2 rows 2 columns, and this is the first one. Plot Tmax underline Boise underline 2013. This I want it to be with a red line. This is Tmax, it should be with a red line. And then hold on, plot Tmin now with a blue line. And then title should be the year, which is 2013. Perfect. Did I ask for anything else? Let me quickly go to the question. Oh yeah, so the axis should be between 1 and 365, and y-axis should be between -50 and 50. So we gotta use the command axis. It's x is between 1 and 365, and y is between -50 and 50. Perfect. Now I'm just gonna copy and paste this. So in the second one, we are gonna use year 2014. The third one, I'm gonna use the year 15. And for the fourth one, I'm gonna use the year 16. If I just evaluate this entire thing, you'll see that I'll have a plot. This is 2013, this is the temperature, maximum temperature, minimum temperature, etc. Maximum temperature, minimum temperature. So 2013, 14, 15, and 16. One thing that you have noticed already is that in this plot, I just assigned the y values, right? So I haven't assigned what the x values are, because what they really, in this case, x values are 1, 2, 3, 4, all the way to 365 or 366, depending on whether this is one of those years. What is it? Oh man, I don't remember the name. But some years are 366 years, and some are 365. So if I just do plot of the y values, I don't give the x values here. X values will be 1 through whatever the size of y is. So for year 2013, I have 365 days. So x will be from day 1, 1, 2, 3, 4, 4 all the way to 365. So x would be 1 through 365, and y would be the Tmax. So that's why I didn't assign the x value. We are going to get back to this point in just a second, but see here it goes from 1 all the way to 365. We didn't assign it, that's the default in MATLAB. We'll have another question to discuss that point. So we're gonna get to that point. Question 7. If we drop a ball from the top of a building 100 meter tall and shoot a ball upward with a 50 meter per second initial speed v0, they reach to one another at some point. Plot x1 and x2, which is the trajectory of the ball going down and the trajectory of the ball going up. Then try in one. So we're going to plot those two trajectories in one plot and approximate what are the x and what are the t values that they clash. So basically, where and when do they clash? Try different ranges of time to find the appropriate time range. The appropriate time range is that see, these values can go negative at some point. But see, this ball is going up, this ball is coming down. If we allow it, it's going to go below 0. We don't want that, so we are going to use different ranges of t to find out what range is good enough. Let me start somewhere. Clear and CLC, get rid of everything. for different t values, we want to calculate x1 and x2. So let's do linspace. Let's do between 0 and 4 seconds. X1 is, see, the question says x1 of t. I'm gonna put it here because it's not gonna work. It's gonna give us an error, but this is an important one. I want to make sure that you understand why this is giving us an error. 100 minus 0.5 times g, which is 9.8, times t squared, which we need a dot, right? Because this is for each element of t, for each time we need to find x1 values. x2 of t, again, this is going to give us an error, but this is important, so I want to make sure that you understand this. 9.8 times t dot squared for the same reason, plus v0 was 50 times t. Perfect. So now if I evaluate this, it's going to give me an error. Array in indices must be positive integers. Ct is 100 values between 0 and 4. So the first element is 0, the second element is 0.04. When we say x1 of t, it means that x1 of 0, x1 of 0.04, x1 of 0.08. The elements, you have element 1, element 2, element 3, element 4, right? So you don't really have element of 0. In MATLAB, you don't have that. In other languages, it's different. But in any language, we don't have element of 0.04, element of 0.08. So see, this 0.04, this cannot be an index for x. So we are going to remove this t. We are going to remove this t. What happens is that if I run this, I'll have t values, I'll have x1 values, and I'll have x2 values. So at t equal to 0, x1 is 100 because it's at t equal to 0, ball is here, right? So ball has not changed yet. So ball has not dropped yet, and this ball has not gone up yet. So x1 is 0, x2 is 0. As the time passes, x1 will come down, x2 will go up. Let's see if x2 becomes negative or not. x2 doesn't become negative, but x1 also doesn't become negative. So looks like we haven't let the ball to go all the way to the ground. Let me increase the time to 5 to see. See, if I increase the time to 5, at some point the first ball tries to go below 0, which is not possible. But there is some point right here, t of 90. So again, t of 1, x of 1, x of x t, the first element of t is associated with the first element in x1 and the first element in x2. The second element in t is associated with the second element in x1, the second element in x2. So in here, the ball, the last time that the ball is negative is at index 90. So if you want to find at what time this goes, this starts to go negative, that's the element 90 in t. If I look at this, this is 4.4949. So instead of 5, I just put 4.5. So the maximum time is 4.5. Now if I run this again, let's see if my x1 goes negative. No, it doesn't. Perfect. So that's good. The other thing that we asked was to plot these two together to see when do they hit one another. See, I can't do plot x1 here because if I just do plot x1, what I see, actually let me do it very quickly and I'll tell you why this is not the proper way. If I look at the x-axis, so the y-axis, it shows between 0 and 100 something, so that's the projectile, the first projectile coming down, this is the second projectile going up, Everything is perfect on the y-axis. But the x-axis, we have an issue. The issue is, why is it between 0 and 100? It should be, it should be between times 0 and 4.5, right? This is the exact same thing that we discussed before. If we don't assign what is the x-axis, it will just go from 1 all the way to the size of whatever you have on the y-axis. So it's important in this case to add t, because each t is associated with one x values. So it's important to put t here. If I evaluate this again, you'll see that, all right, no, this is not going to work because hold on was on. I should have done hold off and then created a new figure, but I didn't. Anyway, I close the previous one. I open I plot them again in a separate file, and you'll see that, all right, now time is going between 0 and 4.5, which is perfect. And then we want to find what time is it that the two of them would hit one another. As you can see, it's about 2 seconds. Again, you can use grid on to see better. Again, right about 2 seconds, the two projectiles hit one another. So this is this question. That was easy. Question 8 we already have done in class. Question 9 again touches upon what we just talked, like if we assign x values or if we don't assign x values, what is the difference? Let's quickly go over this together, because I think this is going to give you some information. So let me just copy and paste y from here into my script. So this is my y value. Let me also copy my x values. Let me do, well, first of all, let me close this one. Because we had hold on, so whatever we plot here is going to be plotted on the previous figure. I don't want that. If I just do plot of y, let's see what happens. So I'm going to run this CLC clear, get rid of everything, and then we define x and y, and then we do plot of y. So these are the y values, and then the x values again starts from 1, go all the way to 7, because we had 7 y values. If I do who here, it will tell me that my variables are x and y. In my workspace, you can see I only have x and y. Who gives me all the variables. And if I do whos, it will give me x has a size of 1 by 7 and y has a size of 1 by 7. So when you see here, it goes from 1 all the way to 7 because my y had 7 values. These are the y values. It's 10, 14, 9, 12, 18, 19, and 20. Perfect. 18, 19, and 20. So that's the matter of this. If I want to open a new figure, I just type in figure. I don't want to lose my previous figure, and I don't want to plot on it. See, I have this figure, I don't want to plot on it, I want a new figure. So I type in figure, and it will open a new figure for me. And then I put plot x comma y here. Okay, I don't need to run figure anymore because figure is already here. No. I messed things up. Let's do it from scratch. See the difference? They are the same, right? So these are they should be the same, because this is both plotting y values. But the issue is x is going from 1 to 7 here, which is this one. But this one, for different x values, so for x equal to 1, y is 10. X equal to 4, y is 14. 7, y is 9. 8, y is 12, 9, y is 18, 11, y is 19, and 14, y is 20. So basically the y values are the same, but the x values you can see here. See right here, x values are different because we defined x values here. Let me go back to this. So this is question 10 is easy, you can do it easily. Question 11, it's again you got to use the mesh grid function. So what you're gonna have to do is you have to define x is equal to linear space between 1 and 5, comma 20, because it asks you to have 20 values. Y, you define linear space equal to linear space from -2, comma 2, comma 10, because you got to use 10 values, and then brackets x, comma y, close brackets equal to mesh grid of x, comma y, and then z is equal to xx squared plus yy squared, yy to the power of 3, so that gives you the z values, and then you can just simply do surf x, comma y, comma z. That will give you this plot. And then question 12 is again similar to question 7. The only important point here is that you define this t value, you have a range, linear space, or whatever and whatever, but this t cannot be the index when you define it. So h is going to be equal to t times v0 times cosine of theta. That's it. It's not h of t when you define it in MATLAB, right? So it's h equal to this and v equal to this, and that's about it. And then you plot it, and everything else is the same as what you had before. All right, so that concludes week 2, and thank you for your attention.